All right, good afternoon, class. We didn't have in-person classes today, but we are going to have some new material. So I wanted to start the recording itself with a little bit of an overview of what we did last week, then move on to the new material that we need to cover for SQL queries, and we'll continue with some exercises at the beginning of the next class, follow up by the new topics. So let's get right to it. All right, so during the last class, we were looking at general SQL queries. We had already seen how to retrieve data and manipulate the data from one single table at a time. So if we want the customer data, we will essentially say, oh, I want to get data from the customer's table. And to specify the attributes, we will specify as like a statement. So if I want to say the name and the customer name, last name and first name, sorry, customer name, and the contact data system, then their first name and last name, we will essentially go and say select the customer name, comma, contact last name, comma, contact first name from the customer table. And if we wanted to filter out some rows, we could say, oh, I only want to see those where maybe the city is Long Beach. So we only see customers from Long Beach area. And that essentially allows us some level of control of the information that we had. The next thing that we were looking at, which was the topic of the last class, was how to get data not just from one table, but multiple tables at a time. The main approach that we had was using a join, or it could be an equi-join where we just do where clause with an equal, or it could be an actual join in the form of a select statement, then a front statement, and within the front statement, we just list a table, then use the keyword join, then the second table, then we specify with an on clause how we're going to be connecting them. So that will be, for example, let's type in an option here. Say, how do I, there. That will be, for example, select all for now. We don't really need specifics from, let's say, the product line table, and then we join it to another table. So join a products table. Now that tells the system, oh yeah, this is what I want to get. I want to get the matchup of these two different tables, but we haven't specified how they're going to be connected. So let me make this bigger so you can see everything in order. So the following thing is just to specify there how they're going to be connected. So we use on, and then the attributes are connected. If we were to look at this particular example, this little matchup actually happens with the product line attribute in both tables. So for example, in the products table, here we have the product line. And in the product lines table, here we have the attribute product line. So if we tell the system these two should be equal, we'll get the match of the two. So we'll say, get in the product lines table and take the product line attribute, and then just match it up to in the products table, the product lines attribute. That's enough for the system to know how to connect them. That was by itself an inner join. And we said inner joins are essentially going to give us the matchup that is common between the two tables. We can make it explicit because right now it is implied, but it's not really explicit. We can make it explicit by using the keyword inner right before the keyword join. And that should be sufficient for us. So let me get rid of these smudges so you can see better. Perfect. We don't need this anymore. Perfect. All right. So let's take this one down. We're going to be focusing on the top portion for now. Actually, we can do it. Let's do it with the employees and the customers. It's going to be a little bit more interesting that way. So let's see the variations that we can get. We look at the matchup between the employees and the customers. We can make it relatively easily here. We can do select all from the employees table, this one right here, and we want to connect it to the customer table right here, so we can get the information about which employees assisted which customers. That's essentially what it's going to be saying. We know that the matchup is done through the sales rep employee number. This one right here is the same value as this one right. This one right here is the same value as this one right here. So we're just going to tell the system these two should be the same. So we tell it on from the employees table. And to simplify, let me use an alias. I'm going to rename employees as the letter E and customers as the letter C. So from the employees table, this one right here, the employee number should be the same as from the customer table, this one right here, dot the sales rep employee number. So the employee number in the employees table should be the same as the sales representative employee number in the customer table. If we get to run this is what we get. We have the matchup of every customer and the employee that assisted them. We see 100 records because it's summarized up to 100 records, but there are more rows available. What we can see, however, is that they are all filled. There's not going to be any employee who hasn't assisted a customer. There is no customer that has not been assisted by an employee. It only has the matchup. That is, by doing it this way, we're getting everything from the customer table, and we are getting we're getting only the part that has a connection between the employees table and the customer table. We don't get everything from either of them. So for the employees, we will get this little chunk right here. For the customers, we'll get this little chunk right here. But employees that have been assisted customers, that is this huge area right here, will not appear in the result. And customers that have not been assisted by the employees, this area right here, will not appear in the result either. To get those, we can modify the query and essentially say that we want to get either everything from the table on the left or everything from the table of the right or everything from both tables, regardless of whether there is a match or not. In this case, employee goes first and customers goes second. So employees is the left table and customers is the right table. We know that because of the way this is screen. It's really on the left of the quality is employee, on the right of the quality is a customer. As simple as that. So if we want to get everything from the employees, we will say, oh, I want to do it's called a left join, which will give you absolutely everything from the employees table, whether there is a match or not, and it will give you the matchup for the customer table. So we can test it out. And we're going to see all of this is the data from the employees table, so it should always be filled. But if you go to the right, we notice clearly here that some data is missing. That is because this is the beginning of the customer table and we don't have data about those customers. These are employees in essence that have not helped any customers. We can get the opposite by doing a right join. And now we get some customers, like here, that have not been assisted by any employees. Or we could get both with a full join. And now here we have a customer that has not been assisted. And if we keep scrolling, we will also find some employees that have not assisted any customers. These guys right here, both at the same time. These are useful to narrow down specifically what we want to get. We could get, typically we want the matchup between the two tables, but maybe we want to see everything but the matchup. Like just maybe we want to see how profitable are customers that have not been assisted? Are they do do they commonly come back and buy more stuff? We will only be able to tell that if we do a right outer join and then just focus on every customer that have a null value for the employee. So definitely useful to identify data that you want. Now, that was the topic for the last class. So that was a quick recap there. For this class, we want to focus on subqueries, which is the idea that we can actually make queries and then feed them to another query as additional processing. For example, this is something that we're already getting. This is a query perfectly working, no issues whatsoever with this. We can always put it in parentheses, give it, and then just feed it like if it was a new table instead of a different query. For example, select all from, and let's just do something related. Say orders. Select all from the orders table. Then we're going to join that orders table, not with any other order that we had, but with the result of this query, that is, with everything that we are seeing right here in the bottom, absolutely everything. How will we do it? Well, the orders table has a customer number, and here we also have a customer number. So we can easily tell the system, oh, you know what? I want to match up the customer column from this new table to the customer column in the orders table. So we can do join and then just list the new table right there. So now all of this becomes a table on its own that we can access, that we can manage, that we can operate on, even from a different query. It just becomes like a source of data by itself. We need to give it a name though. So let's call it a assisted customers table. So, and rather than full join, let's get it so we only see data for the customers that have been assisted. So let's do an inner join. That is this area right here. Customers in the middle that have been assisted in some way. That area in the middle. So we'll get the orders from the customer that have received assistance. That's the benefit of this one. Now, since we are doing a join, this join right here, we will also need to do another connection here. So we can do on from the orders table. Let's call it O. Let's simplify this. O. From the orders table, which we are renaming O, we are going to get the customer number. So we can connect things from there. And then we're going to connect to the customer number as well, but from this new table that we just created. So I'm just going to copy a name, paste it right here, and bam. Now we'll treat this query like if it was a table that exists in our database. So all this is to say that we can actually tell the system that we want to get a query. We're going to get some output of that query, and then we're going to feed it to another query to do something more complex. So it is possible to create what we call subqueries, queries within a different query. So let's backtrack. What are our options for that? All right. So subqueries can actually take one of two forms. They can be correlated or non-correlated subqueries. Non-correlated are the easier ones. That is, non-correlated are subqueries. That is, the query, it are circumstances where we are using two queries at the same time. And the query that is within can run by itself, completely independent of the data that the outer query, the bigger query, is doing. So if we're looking at this is the inner query because it's a full query within a different query. And this is the outer query. So if the inner query can run by itself, then that is a non-correlated query. That is, the result of the two queries is not correlated. They don't depend at all. They don't on each other. You can run one, the inner query, one time, feed the data to the outer query. That one runs one time. Everything gets sorted. And that's what happened here. The inner query, this one ran one time, got the data that we saw before, then fed it to the outer query with a name called assisted customers, and then the outer query did a regular join just to connect the two tables. Relatively simple, two activities, two events. The correlated are more difficult in the way they function. They are not more difficult per se. They just work many more times for any one type of connection that we want to do. So, for example, we can find correlated subqueries when the query inside of the larger query cannot run by itself. For example, in this example here, we are getting the product standard price from the product table. We are renaming that product table as PB. So we just have one table called PB. And then the inner query is also filtering the rows so that we only see the results where the product ID from PB, product ID that we're getting from this table, is different from the product ID that we have from PA. But there's no PA. We didn't describe a PA. This PB here is the table PB here, but there is no PA. Therefore, it cannot run because it's missing data. It's missing data because that is actually data that is in the outside query. So if you cannot run the inner query by itself, that by definition will make this a correlated query because the activity of the inner query depends on the activity of the outer query. That's it. If they're independent, it's non-correlated. If they are dependent on each other, it's correlated. And we all need to pay attention to how they will work based on this. So the correlated subquery, the operation is going to be simple. Whenever we find it, we will execute the inner query one time, and then we're going to take that output and we're going to feed it to the outer query wherever it was called for. Could be called in the select statement, could be called in the word clause, could be called in a having, could be called anywhere. Wherever it is being called for, we're going to take that data and feed it to the location. Now, it needs to match what it's asking. Like, we are not going to feed a list. We're not going to feed a list of values, possible values in a select statement if there's no way of processing that, unless we had something like a count. Like, it needs to fit what the statement in the other query needs. Otherwise, it's not going to run. But we can run them in any section that we want. So, how do they work? Essentially, the idea behind them is that we can write any type of query. Let's call it query one. It runs one time. Then we take the output of this query one and we feed it to a query two to process. The query number two runs again one time, and then you get your output. Whatever it might be. That's going to be your correlated query. The non-correlated query. The correlated one is going to be a little bit more difficult in the way it is going to be processed. The way it will work is that because the inner query cannot run by itself, then the system will try to run that inner query. The first time it will fail because there's not enough data. Once it fails, it knows, oh, I actually need to process the outer query first. And at that point, the outer query starts running. And it will actually run one time for every single row of data that we have. So 1 time per row. So if we had a data like that looks something like this with 4 different rows, then the inner query will run, essentially the outer query will run 1 time for every row that it possesses. It will execute the inner query 1 time. And you might wonder why is that. Actually makes sense if you think about it. The inner query needs to run. What it's doing? If it is in the front statement, it is getting data for the outer query to process. If it is a word clause, it is going to provide a list of values or a given value that needs to be compared to something. So it needs to execute its action, whatever it might be, and it can only row, because it depends on the outer query, it can only row and provide a single value for every single row that we are analyzing. Let's look at this example right here. This one right here. What is it doing? It is taking the product standard price. Let's put it below here so we can see. All right. In here, have the colors inverted. So hopefully that's okay. So it's taking the product standard price. Let's call that product standard price. That's the only cell that is retrieving. So it's a column called product standard price, period. It's getting it from a copy of the product table called PB. So all of that is coming from the copy of the products table that is going to be renamed PB. And that's the full products table. Okay. So you might think, oh, well, it's straightforward. Product table, we look at the products under price column, we retrieve that. And yes, that's correct. That's what we will do here. But then it goes into the word clause. And the word clause is just a filter. It's going to filter what we are seeing. So what is the filter? The filter is looking into each one of these cells and then identifying if we want to keep the value or not. The logic of whether we want to keep it or not is to check if the product ID corresponding to this value. So if we look at the full table right here, it will actually have something like a product ID and a standard price and so many other attributes. So what the filter is doing is checking if the ID of each one of the rows that we have here, let's say this one was 1, this one was 2, and so on. If it exists in the product ID in the PA table. What's PA table? It doesn't exist at the moment. So we need to step back. Right now it's here, and it's a PA to compare to. So its system goes back to the other query, and the other query says, oh, well, let's see what this is doing and where we can find that PA. Well, the other query is getting the product description, the finish, and the standard price from the product table, but this time it's being called PA. That calling it PA in here, it's saying that we are making a second copy of the products table. So it's not going to be the same one. We need to get a second copy of the products table that we're going to be calling PA. We're going to get the data that we need. from that second copy, it's the same source, but a different copy of the data. Those are going to be the 3 attributes that we want from there. And then we're going to check the product ID coming from this PA table to the product ID that we go for this PB table. Okay, so for each one of these rows, we'll have to look at in the source what we'll have to look in the source what the ID is for each one of them. So what will it do? It will just compare that product ID that we're getting to the product ID that we're getting from this result right here, from this PV. In essence, we're going to get 2 copies of a product table. Inner query runs 1 time for every row. The inner query picks up the product ID from that row. Then it compares it to the product IDs from all of the rows that you're getting in the PA copy. And if they match, that row is excluded. If they are different, that row is kept. In essence, what we were saying is from the copy PV, we identify 1 record. Then we identify any record that is not the same record in the copy PA. And based on that, we make an assessment of what to keep on and what to remove. All right. Let me clear this up. Back in a second. Okay. Flores. All right. So I've cleaned it up a little bit just to make a comparison. The inner query retrieves this data. You don't actually see the ID, but it's there. And the outer query retrieves this data. They are the same products, right? So if the product ID 1 is worth 30 and the product, then it's 30 in both sides. 2 is 45, it's 45 in both sides. If 3 is 15, it's 15 in both sides. If 4 is 20, it's 20 in both sides because they're the same thing. So what will this do? It gets the list of attributes. It gets a list in PB, this one right here, and then fits it to the outer query. The outer query needs to call for this list to be made for every single row because it needs to compare if the product ID that is getting in a given row in PA, that is in PA here, it needs to check if that product ID exists in that list. If it exists, that is in the list PB, if it exists, it's going to discard it. So the outer query runs, identifies this data. Then it runs the inner query for the first row. It checks, okay, from this output, Is this ID that we have here in PA the same as this ID we have in PB? Yes or no? Well, in this case, they are the same, so this row is excluded. This one is different, so now we can compare. What is the comparison that we want to do? Is this word clause that we have here. The product standard price from PA, this one right here, needs to be higher than all of the products remaining in the list PB. So this one, 30, needs to be higher than everything that we have in the list PB. So it'll be higher than all of this. If it is, that row is kept. If it is not, that row is eliminated. All right, so is 30 higher than 45? No. So this row is eliminated. We don't keep it. Straightforward for that one. Then we go for row number 2. Well, let's fix this. Well, for row number 2, this is the same ID, so we skip that row. Okay, the standard price is 45. Is 45 higher than 30? Yes. So far so good. We keep it. 2, they're the same, so we ignore it. 3, is 45 higher than 15? Yes, so we still keep it. 4, is 45 higher than 20? Yes, so we keep it. So this is a good one. We keep that one. Then it runs for the third row. Well, is the third row, the third row has a value of 15. We compare with the first one. Is 15 higher than 30? No. So this one fails right away. Then we can go for row number 4. Is 20 higher than 30? No. So this fails again. What do we end up getting here? Just the highest value. All of this was a really quirky way of doing the calculation for the highest value. But it shows the way the corollary queries work. Corollary queries work by getting an inner query that refers to something outside of itself. Because it's referring to something in the outer query, it cannot run by itself. So instead, every time the outer query runs and process one row, that inner query will run one time for that row. So take it with calm, one step at a time, and it will be relatively easy to follow along when to use them. All right. So we have several exercises for these guys here. What I want you guys to do is just practice with this. I'll share the answers for these particular exercises. The activity that we are grading is the one in DataCamp, which has additional practice for this as well. So just finish that one and you'll get the points for the lab for this week. Well, essentially the one we were talking about last week, which is still ongoing. But you have additional practice in here. I'll share the answers for these guys. If you took my IS380 class already, you will familiarize with the subquery portion of exercises. So if so, great. If not, well, I'll be available to answer any questions you may have. So the second part that I want to focus on really is going to be the case logic. And this is what I want to focus on Wednesday, mostly. Case logic does give us a little bit of extra capabilities. Oh, this section is the one for subqueries part 3. It has 3 different exercises with steps in each one of them to make them easier. So all of this, page 10 to 11. Case logic, we have exercises in part 4. I added 4 different exercises. It's page 12 to 13. And what they allow us to do is essentially create new columns. Case logic is a way that we have to create new attributes with a particular value shown based on some equality check. So we could say something like, oh, maybe I want to not show these numbers right here, but instead, if the number is really high, I just want to show the word or the letter H for high. The number is low, just show the letter L. If there is no number, maybe it's an inventory level, then the letters NA for not available or not applicable. It is a way of creating an attribute that has values that are going to be filled in dynamically depending on some condition that we set. In other words, it's a way of adding an attribute column based on if-then scenarios. The way these guys work is that in the select statement itself, we can list attributes and functions perfectly fine. We have described those before. But we can also list the function, the statement case to tell the system, oh, I want to start doing a case logic column. So everything between the case and the end as, right here, end as, will be logic that will be used to determine what value will be present for each row in that column. As simple as that. Anything in between is just going to be a series of if-then scenarios. So in here we have, this is an example actually that it's in data camp. You will see it shortly. In here we have data about soccer matches from the British League, in which we can look at the home team that is playing and the away team. We can see the goals that they score, both home goals and away goals. We cannot see specifically who won, but we can calculate it. If we know a particular game, we can just go for that particular game and essentially associate the relation between the goals that they score as home team and the goals that were scored as away team and determine who won. So that's essentially what's happening here. What do we have here? Select a statement. We have an attribute for date. We have an attribute for the home team ID, an attribute for the away team ID, plain old attributes, no logic in there. Then we have the case logic in here. Then we tell the system that we are getting all the data from a table called match. And we have some filters here. These filters are just to specify which games we're interested in. But for any logic that we need for learning about case logic, we don't actually need to look at this section. Just imagine that we already have all of the data in here. What the case logic will do is just establish conditions that need to be met for some output to be shown. We started by using the keyword case. That is, then after using the keyword case, we use when. We establish an equality. And once that equality is true, what will happen? That will be shown by the keyword then. In this case, when the home team ID is 8455, that is Chelsea, and the goals scored at home are higher than the goals scored away, that is the goals that the home team, in this case Chelsea, score are higher than the goals that were scored by the away team, then by logic, the Chelsea team must have won. So we can just type in or force the system to show Chelsea home win. And we do the opposite in here. Let's do some easier to see examples because this one is a relatively complex case logic in here. So let's look at some of the exercises here. Just try to solve them. All right, so there's 4 different exercises in here. I'm going to let you guys work on the number 5 on your own. I do want to show number 6 because it has some nice functionality, and I want to show you number 7 because it is relatively straightforward. I think it's a pretty good way of understanding what's going on. So let's start with number 7. That's the easiest one. Then we'll move to number 6, which is going to be a little bit more complex. And the other 2, I'll let you guys finish then on your own. So let's change queries in here. Let's sync. There it is. Perfect. All right. Oh, before we can get there, let's look at the table. So let's see up query number 7. The question is, create a query that identifies the status of an order in our database. Before we do anything else, where are the status? They are right here, the status in the orders table. So we're just going to look at that column. What will we do to do that? Well, we can go into the query editor, do select the status from orders. Run it, there it is. Notice that it says ship, some of them is say cancel. If we keep scrolling, there's even some that says some other things like in progress. Well, what are we going to do? We're going to rename them. So specifically, we want to check the status attribute in order to and classifies them based on some criteria. If the status shows the keyword ship, we are going to fill in with the words, the order has been shipped. If it is canceled, we're going to fill it with the keywords, order was canceled. In any other scenario, notice the one that I referred to here, that says in progress, something like that, or any other alternative, we're going to fill in with the keywords pending shipment. So how do we do that? That's the beauty of the case logic. We can fill in relatively easily by making a series of when-then scenarios, which are going to if-then scenarios in Excel or any other programming language that you might see. So to do it, I'm just going to add another attribute. I'm going to keep this column for status and the new names on the right-hand side. So for using case logic, we start with the keyword case. We're going to have a series of word, when, then, and then we're going to end up with an end as, here it is, end as and a name for a column. So we're going to do end as, let's call this a shipment status. All right. Now for this to work, we have to have the conditions in here. Let's say we wanted to include an else and we wanted to include a main condition. Well, let's simplify first. First condition, when Sonic quality will be green here. And then after the then keyword, we specify what is going to be appearing if the equality passes. So where, let's say, the status is equal to the keyword chip, then, and let's double check this, the double quotations, Oracle is speaking about them. Then it's going to actually say shipment in progress. Notice that now it is reading this properly. There's no error anymore. So we can execute this. Yeah, the identifier here should be this one. I think single quotes according to the Visual Studio Code that I have in front of me. Single quotes in both. There is. So notice that now it says ship here. And in this case, it says shipping in progress. It's as simple as that. We just added this status column, it stays there, comma, and instead of another column right away, we use case. Case when the status, this attribute here, is equal to ship, then what happens? And notice that there's no need to be any one given attribute. We could do something like, let's see other attributes that are here. Let's do another condition here. When the order number is equal to, no, actually, let's say higher than 100. Then I order, and that's actually doesn't mean much, but just put in the example that you can use more than one column for reference. You're not limited to any one of them. Here is high order. That doesn't really make much sense, but you can use multiple attributes to determine what's going to appear in here. You can do any type of calculation. In the example that we had in here, we actually used two conditions by using an AND to essentially expand our repertoire of options. We could even use the case logic in the where clause to establish extra filters, which is what happened here. But the logic that what matters is the logic that we use here. So we can control what is going to be appearing. So if we wanted to control, it was the status in three forms. We wanted to control the status when the order was canceled, when the order was shipped, and then for any other scenario, we will just mark it as in progress. So if the order says cancel like it does right here, if the status is cancel, then we want this to say as a keyword here. Order was canceled. Test it again. There is shipment in progress, and if we scroll, here is order was canceled. But now we also have the other scenarios. In this summary, we have two options right now. At least from the one here, this is what I'm looking at. We had two options in the number of rows that we could see. Now that let's scroll down, new ones appear. So we have at least cancel, dispute, in progress, on hold, resolve, chip. So for any one of those alternatives that are neither chip nor cancel, we just want to say pending shipment. Maybe it's not necessary to give so much detail to someone. We can do it like this, pending shipment, which is essentially the same thing that was done in here. And now if we run it, we're not going to see, no matter how much you scroll, we're not going to see these options. We'll say cancel, well, not this option. They will not have null on the side. They will still appear here. They will not have null on the side. That's what I meant to say. So let's run it. Scroll down. And there is the three options, no nulls. If you look at this, all of the options are there. So it's working fine. So case logic is simple. We use a case statement to initiate it. Then we say when, then when some condition is met, then show this value. Else a value. And then we end with the keywords end as, and then that's going to be the name of the attribute, the column. Shipment status, they're the same value. So we do this to have some more control about what the output is going to be. It doesn't give us full control, which takes us to the point that we still need some extra functionality to be able to use SQL and databases as a full programming language. We're going to be starting the discussion for that on Wednesday. We'll continue over the next month or so. So this is a simple example. You have it in the recording. I'm not going to share just yet. I'll share everything once we have all of the solutions done. But you have access to it. You have access to the recording. So let's look at the other scenario here. So we can see something more complex. Here's question number 6. And it's saying, create a query that identifies the level of the employee. Level of the employee sounds interesting. So we can do select all from employees, just to take a look at what's available. Bam, there is. So let's continue. For context, our employees table include a, oops, I didn't add this here. Did I erase it or did I add it? I'll give it verbally anyway, and I'll fix it before sharing with you. For context, our employee table includes a hierarchy of employees where a single employee does not report to anyone since they are the top of the hierarchy. That is, we essentially have a scenario where we have one chief executive person. On their hand, you have a lot of different managers. And under each one of these managers, there would be different staff members. All right. That's essentially how it looks like in our database. The chief officer doesn't have anyone to report to. There's nothing in here to report to. However, every other employee will report to someone. The staff don't have anyone report to them, but they do report to people. The managers have people that report to them, but they also report to someone else. What we want to do is just make a categorization. We don't want to just know that the relationship exists. We want to name it. So we want to say, oh, if we see a row for the chief executive, it should say that that is the top manager. If we see the row for the managers data, then it should say that they are the managers. And if we see the row for the staff members, it should say that they're staff. That's what we want to get at. So where do we get that data? SQL developer, here it is. We look at the data here. We scroll to the right-hand side. This is reports to column. So every employee except the chief has the report to. So we know that the reports to for the chief is going to be a null value. Okay. Oh, second here. All right. So the reports to, let's make this bigger. The reports to is going to be a null value for the chief. So what can we do? We can do a case where the person that has no one to report to is the chief or top manager. So if the reports to is null, then that is the top manager. We need another rule for the managers and staff because, well, it's not easy to differentiate them just by the reports to column. But look at this. This guy say sales rep, and actually the managers say manager. So, isn't that awesome? It is very awesome. So we can exploit that to know which are the managers. So what can we do? Well, we can tell the system, I actually want to see all of the data. Let's say employee number. Actually, just for convenience, I'm going to do the reports to, and I'm going to do the job title. That will get rid of the columns that we don't actually need for this. And then we're going to establish the case logic. So how do we do that? We add a comma to add another attribute. So it's going to appear here on the right-hand side. And the next line, we do a case. And this is going to be, let's call it management level. That's going to be the name of the column. And what are we going to do to fill it in? We're going to do when, then. When, then. I'm going to use spacing to separate them. So when the reports to column is empty, that is null, then the value is going to be top manager. After we're done with that, we can test this out. It will be, this guy will have the value of top manager. Everyone else will be null. So let's do it. When reports to is null, then this value should be top management. Let's test it out. Here it is, top management. Wow, works just fine. All right, now comes the difficult part. How do we differentiate the managers from the staff? Well, again, we cannot tell from the reports too. Arguably, we could make a complex query to figure out if someone reports to them, but that would be too much work. There's an easier way. We can look at the job title itself, see that these guys, actually these four guys have actually three guys. VP of marketing is not a manager. We have three guys that mention in their title that they're managers. So we're going to take those three and call them manager. How do we do that? Well, we do when. If you're going to look at the job title column, then when job title is equal to, and then we need to specify that the title includes the word manager. So if we were to do it X, it will be just manager, but clearly that is not going to work. Oops, let me add the second level. I didn't finish the when then manager. Okay, so that is not going to work because that's not the only thing that I say. It has text before the keyword manager and text after the keyword manager. So we are going to use the percentage sign, which essentially indicates that we want to get any potential variation of text before the keyword. If we put it before the keyword, it represents everything. I want to see everything possible before the keyword. And we are also going to put it after the keyword. That is going to tell us, I want to see any variation before the work manager, but the manager keyword must be there, and a variation after the keyword manager, but the manager keyword must be there. We'll run it again. Do I have a typo? Oh, right. It cannot be equal. Equal fixes it, so it is exactly that value. We need to use a keyword like. Like is going to be any variation of this. And there is. So like is lower restriction level than the equal sign. The equal sign will be has to be exactly this. Even if we put these values, like would allow you to have variation. So there we have. These guys are now managers, just like their title says. What do we do with the rest? Well, we have a keyword for that, else. So if they are neither a top manager or a regular manager, they're just going to be a staff, else a staff. So if we run that, everyone else is now called staff. So it gives us plenty of flexibility there. And notice how we could do this with one single attribute being processed in different ways, or even two attributes being used at the same time to determine what's going to be shown in that new column that we're making. It's all up to us, but it's plenty functional. So let's put this guy here. I'll fix this in a moment, but the idea is stop. It's actually here. And a single employee does not report to anyone since they are the top manager of the hierarchy. That's what we had there. All other employees are either managers or regular staff. If an employee reports to someone and they are, let's simplify it. If an employee does not report to someone, they are the top management or top manager of the company. If the job title mentions the keyword manager, they should be categorized as a manager. Otherwise, the employee should be identified as a staff member. That's about it. So the other exercises that we have are going to be variations. This one is equalities based on credit limits, stock levels, sales performance. Actually, I didn't add the stock level one. No, so it's fine. It's credit limits and sales performance. But we can do the same for stock levels. Like when a product is out of stock, just show there that it's out of stock. All right. So that's it for now. We're going to be resuming this in the next class. Then we'll go into how to make our own functions and procedures so we can make something more complex, like an automatic application that does all of this categorization every single day at the end of the day, and then makes a report or maybe orders new material if there is no material, no stock available. So that's the type of functionality that we want to add. All right, have a great day. See you guys on Wednesday.